So what actually happens when you just hand the world's most advanced AI the keys to the Internet's foundational code?
Well, you find out pretty quickly that it's all broken.
Right. Like in just 30 days, it finds 10,000 critical reasons why the whole thing should have collapsed yesterday.
It's honestly staggering.
It is. So, welcome to today's deep dive, everyone. We're bypassing all the usual small talk today because we've got a lot of ground to cover from a single, incredibly dense source.
Yes, we are pulling entirely from Aaron Rose's The Tech Reader AI Digest for today, which is Friday, May 22, 2026.
And the mission for you, the listener, today is, well, it's about understanding a massive structural shift happening underneath the entire tech industry.
Exactly. We're moving way past the era of simply asking, what large language models can generate.
Yeah, the cute chatbot phase is over.
Right, it's over. We are now looking at how autonomous AI is fundamentally rewriting global security, the underlying economics of compute, and really the whole structure of trillion-dollar public markets.
Okay, let's unpack this. Let's jump straight into that first number because 10,000 vulnerabilities in a single month is, it's hard to even wrap your head around.
It really is a scale we haven't seen before.
So Anthropic just released their first progress report on Project Glasswing, and they gave roughly 50 partners early access to their Claude Mythos preview model.
Just 50 partners.
Right, a small group. And they pointed it at critical path software infrastructure. And it immediately identified over 10,000 high or critical severity flaws.
And what's fascinating here is that the scale of that discovery forces a total reevaluation of how we do semantic code analysis.
Break that down a bit for us, because before this, we were just using, automated scanners?
Right. For years, automated security scanning relied on rule-based fuzzing.
Fuzzing?
Yeah, fuzzing, which basically means you throw random garbage data at a program and just see if it crashes.
Okay.
Or you look for known, very rigid patterns of bad code. It is essentially a really sophisticated spell checker.
Ah, I see.
It catches obvious syntax errors or, known typos, but it has absolutely no idea what the story is actually about.
So it completely misses the plot holes.
Precisely. It misses the plot holes. But Claude Mythos, it acts like an expert editor.
Okay.
It actually understands the context, the intended logic, and the flow of the application.
Which a spell checker can't do.
Exactly. So it can look at a piece of code that is syntactically perfect, mathematically sound, but logically flawed in a way that allows an attacker to, say, bypass authentication.
Wow.
And that level of deep semantic understanding is why Cloudflare, just on their own, found 2,000 bugs in their critical path systems using this specific model.
2,000, just at Cloudflare. And the digest notes something crazy about those Cloudflare bugs.
Yeah.
The AI's false positive rate is actually lower than their human security researchers.
Which is the detail that completely flips the script.
Right. Because historically, if you run a static analyzer, it spits out like a phone book of alerts.
Oh, yeah, thousands of false alarms.
And then a team of junior engineers has to sit there and spend 3 weeks manually verifying which ones are actually real.
It's exhausting work.
But if the AI is more accurate than the humans filtering it, you basically skip that entire triage phase.
You skip it entirely, and Mozilla experienced the exact same acceleration.
Oh, right, with Firefox.
Yeah. They tested the Mythos preview on Firefox version 150, and they fixed 271 vulnerabilities in that single release cycle.
271.
Right. Now, compare that to Firefox 148, where they used the previous frontier model, which was Claude Opus 4.6.
Okay.
They found a tenth of that number. So the leap in reasoning capability between these model generations is it's compounding rapidly.
It's a 10x jump, and there's a specific bug in the digest that really illustrates this leap. It's the one they found in Wolf SSL.
Ah, yes, CVE 2026-5194.
That's the one. And for anyone listening who doesn't know, Wolf SSL is a cryptography library embedded in billions of devices. We're talking everything from your smart thermostat to massive enterprise routers.
It's everywhere.
And this specific flaw would have allowed an attacker to just forge security certificates.
Which is terrifying because a forged certificate completely breaks the trust model of the entire internet.
Yeah, explain why that's so critical for the listener, like on a day-to-day basis.
Okay, to put it in perspective, think about your bank accounts. Your web browser relies on these certificates to verify that the server you are talking to is actually your bank.
Right.
And not, some server sitting in a basement halfway across the world.
So without that verification, an attacker could intercept your traffic, present a forged certificate that your browser accepts as perfectly valid, and just serve you a pixel-perfect replica of your banking portal.
Exactly. And the padlock icon in your URL bar, it would be locked.
Oh, wow.
Your browser wouldn't throw a single security warning. You would type in your credentials and you're done. They have your info.
And that vulnerability has just been sitting quietly in the open source code for years, completely invisible to traditional scanners and all of those human audits.
It's just waiting there.
But now that Mythos has uncovered it, along with, 9,999 others, we hit this core structural shift that the digest points out. The bottleneck in cybersecurity has permanently moved.
Yes, because we used to struggle with detection.
Finding the needle in the haystack.
Right. But detection is now scaling at the speed of compute. So the new critical bottleneck is remediation, fixing the bugs.
Right, because it's like hiring a hyper-efficient home inspector who suddenly hands you a 10,000-page report of termites in your foundation.
That's a great way to put it.
I mean, it's great that you know they're there, but it's terrifying because you don't have enough carpenters to actually fix it.
Exactly. Anthropic is finding these flaws infinitely faster than human fingers can actually type the patches.
Yeah.
In fact, the report notes that open source maintainers are literally begging Anthropic to throttle their disclosure rate.
They're asking them to slow down the AI.
Yes, they are completely underwater. Because it takes an average of 2 weeks for a human developer to understand the AI's bug report, write a secure patch, test it, and merge it.
2 weeks per bug, which creates just a terrifying window of exposure.
Absolutely.
Because if you think about your own data and apps, if you're running a major enterprise, you are suddenly looking at a backlog of thousands of critical patches. Your team physically cannot implement them fast enough.
And you have to assume the offensive side, the state-sponsored hackers, the ransomware syndicates, they are either already using these same AI techniques or they are, months away from doing so.
So the structural defense of the internet is currently relying on the hope that human hackers are too slow to exploit the holes we now know exist.
Right. Which is not a great defense strategy. Now, Anthropic's short-term answer is their Claude security beta, which attempts to auto-generate the patches.
So AI fixing AI problems.
Exactly. And they successfully fixed over 2,100 enterprise vulnerabilities in 3 weeks using a slightly older model.
Okay, that's something.
But here's the catch. The reliance on AI to fix the problems created by AI auditing introduces a massive demand for raw compute.
Because you have to automate the whole pipeline.
Right. Finding the bug, writing the fix, testing the fix, deploying it, doing all of that requires complex autonomous systems.
Which means developers are running massive agentic workflows.
Yes.
So for the listener, instead of a human prompting an AI once and getting an answer back, you have an AI agent that is given a goal, like patch this repository.
Right. It operates independently.
And it continuously loops. It reads code, writes a fix, runs a test, sees the test fail, rewrites the code, and loops again and again until it succeeds.
And running those continuous loops burns an astronomical amount of compute.
Yeah.
In the language of LLMs, it consumes millions of tokens. A token is roughly, a piece of a word.
Okay.
So when your agent is iterating autonomously over and over, it is chewing through tokens constantly. And that raw material, the literal cost of a token, dictates the economic viability of your entire engineering department.
Okay, so if AI is now auditing and writing our code at a scale humans can't keep up with and burning all these tokens, the next logical question is, whose AI infrastructure are developers actually using to run all these massive agentic workflows?
And that economic reality leads us directly to the second massive story in the digest.
Right. OpenRouter.
Yes, OpenRouter, the world's largest aggregator for LLM APIs, just published their usage data. They basically sit between the developers building these tools and the models themselves.
So they see all the traffic.
They see everything. And according to their data, Chinese models now power a whopping 61% of global developer API usage on their platform.
61%.
Yeah, that is up from less than 2% in late 2024. And the kicker, almost half of OpenRouter's user base is American.
Okay, the U.S. headlines are always entirely dominated by Anthropic, OpenAI, Google.
Right, the big three.
But the developers actually deploying production workloads, the ones building these agentic workflows we just talked about, they are quietly migrating their infrastructure to Chinese models. Things like Minimax, Kimi, Zipu, and Alibaba's Qwen.
It's a massive shift happening completely under the radar of the general public.
But wait, I have to push back on the logic here.
Okay, go ahead.
If I'm building an autonomous coding agent, I am handing it access to my proprietary code base,
Yes, you are.
the intellectual property of my startup. So wait, is this just developers compromising on quality to save a few bucks?
Not at all.
Because if I'm running a complex coding agent, why wouldn't I use the absolute best model available? You're telling me American developers are actively routing their most sensitive core IP to servers in China.
It sounds crazy, right?
What about data privacy? What about latency? Or the risk that geopolitical sanctions could literally shut off your API access overnight and just kill your entire product?
Those are the exact risks security teams have been screaming about for a year.
So why do it?
Because the economics are so overwhelmingly skewed that raw business logic is overriding security posture. Look at the specific performance data in the digest.
Okay.
It is not a compromise on quality. The Chinese model, Minimax M2.5, scores an 80.2% on standard software engineering benchmarks.
In clog.
Anthropic's Claude Opus 4.6 scores an 80.8%.
Wow. They are functionally tied.
Exactly. They are both frontier-level models. But the unit economics are in entirely different stratospheres.
Hit me with the numbers.
Claude costs $5 per million tokens. Minimax costs 30 cents per million tokens.
30 cents.
Yes. It is nearly 17 times cheaper for the exact same level of reasoning.
Imagine running a startup, right? If you could cut your server costs by 17x for the exact same product quality, wouldn't you? It makes the whole geopolitical tension a really relatable business dilemma.
It really does.
But let's break down how that 17x gap is even physically possible.
The hardware required to train and serve these models, the NVIDIA GPUs, they cost the same globally.
Roughly, yes. And if anything, export controls make it harder and more expensive for Chinese labs to get the compute. So how are they undercutting the U.S. market by that much?
Well, if we connect this to the bigger picture, it comes down to a combination of architectural efficiency and state-subsidized energy.
Okay, explain the architecture part first.
Chinese labs recognized early on that they couldn't just brute force their way to scale, specifically because of those chip restrictions.
Right, they didn't have unlimited access to the biggest GPUs.
Exactly. So they heavily optimized their architectures. They leaned into smaller, highly specialized, mixture of experts models much earlier than the U.S. labs did.
Mixture of experts. What does that mean in practice?
It means instead of firing up a massive generalized neural network for every single prompt, the model only activates the tiny specific subnetwork needed for that exact coding task.
Oh, I see. So it's way more efficient.
Hugely more efficient. And then you add in massively subsidized industrial electricity from the state to power their data centers.
Right.
So their inference costs absolutely plummet.
So if you're an American CTO looking at your AWS bill and you see that your agentic workflows are burning, say, 100 grand a month on Claude,
Yeah.
and you realize you can get the exact same output for $6,000 a month on Minimax.
The math makes the decision for you.
Your risk of an API ban suddenly feels like a future problem, while your runway is a today problem.
And the implications of that highly rational economic choice are profound. The U.S. is definitely maintaining a lead in the raw capability of frontier models.
Sure.
But the actual day-to-day execution of the AI economy, the autonomous workflows, the code generation, the data processing, the reality is that the electricity, the compute value, and the infrastructure for these agentic workflows are running on the Chinese grid.
American intellectual property is flowing across the Pacific, not through espionage, but through standard API calls driven by an unbeatable price war.
Exactly. And that dynamic is completely unsustainable for U.S. AI labs. They are pouring billions into training these models, only to have their API revenue gutted by competitors operating at a 94% discount.
Which means they need cash.
Yes. Massive, continuous infusions of public capital are completely unavoidable now.
So when you have this level of intense global cutthroat competition over pennies per token, while simultaneously building tools that can audit the entire internet in a month, how do you even begin to value these companies?
Well, the public markets are about to try, which brings us to the third big story. The $3.7 trillion tech reckoning.
Yeah, the AI IPO sprint. The digest covers this tidal wave that's about to hit the public markets. Today, OpenAI officially filed its confidential S-1 paperwork with the SEC.
Right.
And they are targeting a public listing in September with a valuation approaching $1 trillion.
This raises a really important question for the industry because let's clarify what a confidential S-1 actually does.
Go for it.
When a company goes public, normally they have to open their books to the world, But under the JOBS Act, a company can file confidentially, meaning the SEC reviews their financials, but the public, and more importantly, their competitors don't get to see those numbers until 15 days before the roadshow.
Just 15 days.
Right. And in this hyper-competitive market, those 15 days are crucial. OpenAI is shielding its true burn rate, its massive compute costs, and its exact API revenue margins from Google, Meta, and Anthropic for as long as legally possible.
Because when that document drops, the entire narrative around AI economics shifts from, venture capital hype to harsh Wall Street reality.
Exactly. For the first time, OpenAI's true revenue will be public. We will finally see if the unit economics of operating a frontier model actually makes sense, or if they are bleeding money on every API call just to maintain market share.
And OpenAI is not doing this in a vacuum. The digest maps out this wild 6-month window of tech liquidity.
It's unprecedented.
Elon Musk's SpaceX filed its public S1 just 2 days ago, aiming for a late June listing at $1.75 trillion.
Wow.
Then you have OpenAI in September at $1 trillion, and Anthropic is targeting October at $900 billion. Combined, that is a $3.7 trillion IPO wave crashing into the market simultaneously.
The sheer gravity of $3.7 trillion will suck the oxygen out of every other sector. Institutional investors only have so much allocation for tech.
All right, they're going to be forced to pick winners in real time.
And the timing of OpenAI's filing is wild.
Oh, this is the craziest part. The digest points out the timeline of the Musk versus Altman trial. It just ended this past Monday, with Altman winning.
Right.
And here's where it gets really interesting. 4 days later, on Friday, OpenAI files their IPO paperwork. 5 days from verdict to IPO filing.
It's no coincidence.
No. It's like they were sitting at the starting line, revving the engine, waiting for the legal traffic light to turn green so they could just sprint to the banks.
The litigation overhang was likely the final roadblock to their public offering. With that cleared, they are accelerating immediately.
Yeah.
But as OpenAI races to the public markets, there is a subtle indicator in the digest's quick hits section suggesting the technical edge might actually be shifting away from them.
The talent migration.
Yes. Andrej Karpathy, one of the original co-founders of OpenAI and just a massive figure in the AI space, just announced he is joining Anthropic to start a new pre-training team. And in Silicon Valley, tracing the movement of elite engineering talent is often the most accurate way to predict the next paradigm shift.
And it is not just Karpathy, right?
No, it's a wave. The digest lists chief technology officers from major companies, Workday, Instagram, Box, U.com, Adept AI, who have all recently resigned from these massive executive roles to join Anthropic.
And the crazy part is, they aren't going over to be executives.
No, they're not.
They are joining as individual contributors. They're stepping down from managing hundreds of people just to write code on the front lines at Anthropic.
Right.
Why would a CTO take what looks like a massive demotion?
Because they want to be at the absolute edge of the new frontier, and they believe Anthropic has solved the next major hurdle.
Okay, what hurdle?
Well, for the last 5 years, the industry has relied on scaling laws. The idea that if you just throw exponentially more GPUs and more data at a model, it will linearly get smarter.
Brute forcing it.
Exactly. It's a brute force approach. But you eventually run out of quality human data to feed it, and you run into the physical limits of power grids to run the GPUs.
Which is exactly where we are now.
Right. And Anthropic's bet, which is attracting all this top-tier talent, is on AI-assisted research.
Me.
Instead of just scaling up brute force, they are using their current models to fundamentally redesign the underlying architecture of their future models.
Oh, wow.
They are automating the research process itself, creating models that learn more efficiently rather than just consuming more data.
It's the difference between trying to beat a faster car by just strapping a massive rocket to it versus using a supercomputer to design a perfectly aerodynamic, frictionless engine.
That's spot on. And if Anthropic has actually cracked that if they can achieve frontier performance without the exponential compute costs of brute force scaling, it adds massive pressure to OpenAI's public debut.
Because it poses an existential threat to that $1 trillion valuation they are trying to sell to Wall Street.
Exactly. The market is going to be pricing these companies based on who has the sustainable path forward. And that pricing exercise, it isn't just Wall Street news. It will dictate the resources, research, and deployment of the AI products that you use every single day.
Right, it affects everyone. So looking back, it really forces you to look at the entire landscape we've covered today as one interconnected ecosystem.
It really is all connected.
We started with Claude Mythos, uncovering 10,000 foundational bugs in a month, proving that semantic AI can understand complex systems better than human auditors.
Right.
And then that capability requires massive autonomous agent workflows, which burn so much compute that American developers are literally migrating 61% of their usage to highly optimized, state-subsidized Chinese models just to survive the cost.
Just to keep the lights on.
And that relentless pressure on unit economics is forcing a $3.7 trillion sprint to the public markets to secure the capital needed to fund the next paradigm of AI-assisted research.
Every single piece of this digest points to a singular underlying reality. The speed of the machine is now dictating the pace of the industry.
Yeah.
We saw it explicitly with Project Glasswing. The AI can identify vulnerabilities at a volume and velocity that human open source maintainers physically cannot patch.
They're literally begging them to stop.
Right. The friction is no longer in the technology. The friction is in our human capacity to keep up with it.
Which leaves us with a critical and honestly kind of terrifying question to consider as these multi-trillion-dollar companies go public.
Let's hear it.
If our human infrastructure, our developers, our security teams, our legal frameworks is already breaking under the speed of AI simply finding bugs and writing code,
Right.
what happens when we start handing over strategic control? I mean, when these autonomous agents are deployed to make real-time financial, corporate, and infrastructure decisions at that exact same velocity, can our regulatory and market institutions possibly adapt fast enough?
It's the ultimate question. It completely challenges the core assumption that we can regulate or manage this technology using 20th century institutional frameworks.
Or are we just building a world that operates on a clock speed we are permanently locked out of?
It's a completely staggering shift to think about next time you see a tech IPO cross the ticker.
It really is. Well, thank you for joining us on this deep dive. Keep questioning the tools you rely on, look closely at the infrastructure running silently in the background, and we will catch you next time.